Welcome to Daily AI Brief, where we delve into the cutting edge developments shaping the AI landscape. Today, we have an exciting slate of topics, from groundbreaking frameworks to advanced models ready to redefine tech innovation. In this episode, we'll explore NVIDIA's Molt, AMD's latest language model, and new advances in AI training optimization. Plus, we'll cover the latest in time series forecasting and dig into a novel video generation framework. Let's jump right in. Let's kick off with NVIDIA's latest gem, Molt. Released on July 22, 2026, Molt brings new energy to reinforcement learning, RL, especially for Agentic RL research. As a PyTorch-native framework, NVIDIA's Molt focuses on simplifying complex RL processes through a compact, clean codebase designed to invite contributions and help researchers quickly navigate through its structure. Technically speaking, Molt integrates seamlessly with existing PyTorch workflows. This means it's positioned perfectly for rapid prototyping and exploration, facilitating the smooth implementation of agentic RL models. With end-to-end algorithm flows pre-configured, researchers can experiment not only rapidly, but also effectively. Molt's open-source nature, combined with its inclusion of Docker containers and recipes, allows users to easily reproduce results and trace algorithmic processes, thereby encouraging collaborative refinement and innovation within the community. Molt excels in numbers as well. It achieves statistical parity with more established Megatron-based stacks, promising similar performance metrics while allowing for incredible scalability. Specifically, Molt supports model parameters ranging from 4 billion to a staggering 700 billion, with expert parallelism reaching up to 256. This promises significant resource efficiency and makes it an attractive option for enterprise-level applications focused on large-scale RL solutions. However, the specifics of these benchmarks are not fully transparent, leaving a gap in detailed performance assessment. Despite Molt's scalability, its reliance on PyTorch may pose integration challenges for organizations with existing frameworks that are not PyTorch-based. Alternatives might offer other advantages, emphasizing aspects such as robustness or specific optimization features. For those interested in getting hands-on, NVIDIA provides access through its official GitHub repository. The resources available there, including containers, are key to quick exploration and testing of RL algorithms. Comprehensive documentation offers detailed insights and examples, streamlining the adoption process even for newcomers. Molt represents a significant shift towards simpler, yet highly scalable RL frameworks, appealing to well-funded entities looking for cutting-edge solutions. It opens doors for faster innovation cycles in RL research, potentially lowering entry barriers for newcomers while accelerating the development of advanced applications. As its adoption grows, Molt might redefine standards in the RL framework domain by focusing on usability alongside performance. Next, we turn our attention to AMD's significant entry into the open-source language model arena with the Instella-MoE 16B-A3B. This model, designed as a mixture of experts, MoE, is ambitious, featuring a total of 16 billion parameters, positioning it to efficiently tackle large-scale natural language processing (NLP) tasks. The Instella-MoE model capitalizes on the mixture of experts architecture, which is revolutionary in its ability to route inputs through only a subset of the network's total parameters. This approach not only enhances computational efficiency, but also reduces the overall energy expenditure typically associated with running large-scale models. The architecture includes several key components, such as gated multi-head latent attention, gated MLA, designed to improve processing efficiency by selectively focusing on different parts of the input data. Also, the FARSKIP collective connectivity further optimizes model performance by streamlining communications across the network layers. Running on the AMD Instinct MI300X and MI325X GPUs, this robust framework is further supported by the AMD ROTM software stack, providing a well-integrated hardware-software solution that maximizes computational returns. These GPUs are equipped to handle significant computational loads, which is crucial for running and fine-tuning models with 16 billion parameters. Despite the enormity of the model's size, only 2.8 billion parameters are active per token, making it both vast and efficiently optimized. In terms of benchmarks, while AMD claims competitive performance, specific metrics haven't been thoroughly detailed, leaving a gap for third-party validation. Despite this, the promise of the Instella-MoE lies in its full open access nature. AMD has released the model's weights and training configurations, inviting the global research community to innovate and advance this foundation. The model's capability to manage large datasets, potentially exceeding 1 trillion tokens, underscores its potential impact in fields demanding sophisticated NLP solutions. However, the model's success will hinge on a few pivotal factors. Firstly, documentation quality and the robustness of community support will play crucial roles in its widespread adoption. Given the model's complexity, scaling it effectively presents challenges, especially in environments lacking high-performance computational resources. For those keen on exploring AMD's offering firsthand, the model's artifacts and further resources are available on platforms like Hugging Face, with comprehensive setup instructions provided by AMD. This invites both practitioners and researchers to engage with the model, offering a sandbox for testing and exploring potential applications. The Instella-MoE 16B A3B has the capacity to democratize access to cutting-edge NLP tools, stimulating a new wave of open-source developments. It represents a potential watershed moment in which community-driven innovation might lead to new benchmarks and applications across sectors like healthcare, finance, and education. However, the competitive landscape is ever-evolving, and ongoing advancements from industry peers will likely influence the journey of this model integration into real-world applications. NVIDIA's Transformer engine is making waves in the AI domain for its ability to significantly accelerate the training of transformer models. It does so by leveraging cutting-edge fused kernels and optimized tensor scaling techniques, achieving up to 6 times faster training speeds without compromising model accuracy. At the heart of the Transformer engine's technological advantage are its advanced software algorithms that support mixed precision formats, specifically FP8 and FP16. These formats enable the model to balance computational workload and precision effectively, thereby enhancing performance and throughput. The system further integrates with NVIDIA's Megatron core, boosting model parallelism, which is crucial for managing large-scale models like transformer-based architectures. This enhancement is particularly notable given the complexity and size of current AI models. To delve into the specifics, NVIDIA reports a breathtaking speed-up in training, where a model like Megatron 530B, previously taking 7 days to train, can now be completed in just 20 hours. Additionally, the engine offers up to a 93% speed increase for GPT-based models and a kernel-level performance boost ranging from 1.3x to 2.1x for mixture of experts (MoE) models. However, it's important to highlight the considerations and potential limitations. The actual performance improvements can vary based on factors such as the model architecture, dataset, and hardware configuration. Compatibility with existing frameworks like TensorFlow and PyTorch is generally seamless, yet it might pose integration challenges depending on the specific setup, which is crucial for harnessing the full potential of the Transformer engine. For those eager to harness these advancements, practical steps include experimenting with NVIDIA's provided examples in the Transformer engine documentation and integrating these into existing workflows. This strategy not only provides immediate efficiency boosts, but also offers a benchmark against previous models to quantify improvements. Ultimately, NVIDIA's Transformer engine signifies a pivotal shift in AI model training, a potential game changer for performance standards in the industry. By reducing training times and enhancing resource efficiency, it opens the doors for faster deployment of AI models, lower energy consumption, and reduced computational costs, possibly democratizing access to state-of-the-art AI capabilities, even for resource-constrained organizations. TimesFM 2.5 is a revolutionary development in time series forecasting, launched by Google in September 2025. This tool sets a new benchmark by considerably reducing the parameter count to 200 million, which is a 60% reduction from its predecessor, while simultaneously expanding the context length to 16,384 time points, a substantial 8-fold increase. This combination dramatically enhances its predictive capability and efficiency. The architecture of TimesFM 2.5 is decoder only, specifically optimized for time series tasks. It meticulously implements rotary attention mechanisms, which significantly boost its ability to understand temporal patterns. Additionally, it utilizes QK normalization and per-dimension attention scaling to refine its focus on detail, allowing for more nuanced predictions. A standout feature is its continuous quantile forecasting, which supports probabilistic predictions for up to 1,000 steps ahead. This feature is essential for creating a rich tapestry of possible future scenarios, as it accounts for uncertainties. It also smartly restores covariate support for external factors such as holidays or sudden promotions, adding layers of context often missing in traditional models. TimesFM 2.5 distinguishes itself through numbers and performance metrics. It consistently outperforms traditional models like ARIMA by 15 to 25% in critical sectors such as retail and finance. These enhancements are the result of comprehensive pre-training on an expansive dataset of 400 billion real-world time points, ensuring state-of-the-art accuracy metrics on the GIFT-eval benchmark without domain-specific training. However, users and developers should be mindful of several challenges when implementing TimesFM 2.5. Its ability to generalize across specialized domains hasn't been extensively tested, and the scalability of the model in handling massive datasets remains uncertain. Furthermore, integration with platforms like BigQuery requires a proficient understanding of SQL. To fully leverage the capabilities of TimesFM 2.5, users should delve into detailed documentation available on Hugging Face. This exploration provides hands-on experience through the GitHub repository and enables trial forecasting using BigQuery's native integration, which is ideal for evaluating real-time applications in business settings. In summary, TimesFM 2.5 not only advances forecasting with precision and expanded context, but also underlines the potential for data-driven systems to enhance business decision-making, fostering a paradigm shift towards more intuitive and responsive predictive analytics solutions. Seedance 2.5 has launched with a focus on enhancing the quality and efficiency of AI-driven video generation, pushing the envelope for narrative coherence and storytelling in digital content creation. The core innovation of this release lies in its structured prompt framework, which comprehensively addresses previous challenges faced by creators, such as character drift and awkward editing cuts. The new framework comprises 6 essential elements: subject, action, camera, lighting, style, and audio. This detailed structure is designed to facilitate the seamless production of 30-second video clips in a single pass. By maintaining a coherent story arc and visual consistency, Seedance 2.5 reduces reliance on extensive manual edits, which, in the past, were necessary to stitch fragmented scenes coherently. According to internal performance metrics, adopting Seedance 2.5's structured approach could reduce editing time by up to 30%. Creators can now segment their videos into timed beats, a strategic method that upholds narrative flow, allowing smooth transitions and more engaging content. This approach not only enhances viewer experience, but also empowers marketing teams to produce high-quality outputs swiftly, addressing the ever-growing demand for compelling video content in the digital landscape. However, alongside these advancements lie certain trade-offs. The platform's ability to maintain consistent character behavior throughout all timed beats requires further evaluation. While comparisons with peer models like Smart Director are still underway, Seedance 2.5 has already demonstrated its prowess by tackling issues historically faced by earlier versions. This positions Seedance 2.5 as a potential game-changer in maintaining narrative pacing. For teams transitioning to Seedance 2.5, mastering the new prompt segment structure may initially introduce complexity to existing workflows. There is also uncertainty surrounding how effectively the platform will compare to established models, leaving room for user skepticism. To make the most of Seedance 2.5, users are encouraged to explore the official Seedance blog, which offers a comprehensive guide to utilizing prompts effectively. Integration into existing content workflows can be streamlined by consulting the API documentation. Engaging with community forums for exchanging prompts and narrative techniques can further enhance users' command of the tool. Seedance 2.5 is poised to redefine the AI video generation landscape by embedding narrative consistency within each clip. This future forward approach offers new opportunities for creatives and marketers to produce content that resonates more deeply with audiences, potentially transforming industry benchmarks and setting new standards for coherent storytelling in AI generated videos. That wraps up today's deep dive into the latest transformative changes in AI technology. We explored NVIDIA's groundbreaking Molt and Transformer engine, AMD's open access to advanced language processing with Instella-MoE, Google's innovative TimesFM for forecasting, and Seedance's novel approaches to video generation. Stay tuned tomorrow for more cutting-edge AI insights. Until then, keep innovating.